Got a pretty quick one here. We need to simplify the square root of 12x to the fifth. Okay, well the 12 is not a perfect square, so we need to see if we can factor it, or factor a perfect square out of it. So what are my perfect squares? Well, 2 squared is 4, 3 squared is 9, 4 squared is 16, and I'm probably not going to be able to take a 16 out of 12, so I'll just stop there. Okay, 12 doesn't divide by 9, but you probably already realized it divides by 4. Okay? So I can take a 4 out of that. It's going to become the square root of 4 times 3x to the fifth. Okay? And the reason we do that is because when we take the square root of 4, what we get is 2. So that's going to come out and be 2 square root of 3x to the fifth. Then how do we deal with the x to the fifth? Well, there's multiple ways you can do it, but the way I'm going to try to show you right now is like this. A square root means we can take out 2 x's at a time, and what I mean by that is that the square root, so a square root has an index of 2, of x squared, the square root and the square cancel each other out, they're opposites, and that's just x. So for every x squared that we have in here, we can take out 1x. For every x squared, we can take out 1x. So this would be x squared times x squared times x to the first. Right? That's x to the fifth. If you add those all up. Another way to think about that, 5 divided by, whoops, not by 4, by 2. 5 divided by 2 is 2.5, which means we can take out 2 x's and leave 1 behind. Okay, so either way you look at it, so this comes out as an x, and this comes out as an x. So we have 2x squared times the square root of 3x. And then that's your final simplified answer. Just look at the index, and it tells you how many you can take out at a time. Then you separate that, whatever that power is, to see how many you could take out. All right, that'll do it for that one.